and we will start our second lecture of the update week. And this lecture will be by Krišjānis Rijnieks. And if you have any questions, please ask them or text them in the chat, or if you're watching on YouTube, you can also ask your questions there. I will check the questions on YouTube and ask them to Krišjānis myself. So if Krišjānis is ready, then we can start our lecture.
Yeah, there's some sort of a feedback, so somebody has to mute their microphone. Oh no, it was just me with an open YouTube window, sorry. So yeah, the live stream started. It's so nice. Hello. I am Chris. Thanks for inviting. I'm really happy to receive these invitations from MP Lab in Liepāja on a I think twice a year, usually in spring and then in autumn. And I'm very glad to share whatever is happening in my life with the network of MP Lab and Liepāja University. So really glad to be here. Let me share the screen. I would really like to be there physically, but this year is as it is. So let's try to get the best out of it. So yeah, so that's the title picture that I also sent for advertising purposes. So it's in the title picture, you can see that there's a 3D printed part in the foreground and then a CAD model of it in the background. So which is sort of an illustration about what I'm going to talk about. It's how you get from the CAD part of the design to the actual physical part of the design, and what are the spaces and sort of more like spaces, not so much industry as in the title, but more like spaces that are dealing with it. So yeah, about me, so that's my name. And if you are interested more about what I do and what are the projects that I have done in the past, then you're welcome to visit my website. I have been living and studying and doing different things, and mainly these 4 cities, of course, during when you're traveling during summer and vacations or whatever, then you're visiting more, but these are the 4 main ones. I studied painting and new media in Milan during my Erasmus studies. Then after graduating the Latvian Academy of Arts, I went to Helsinki to do master's degree in new media. And then while studying, I went for an internship in Berlin, in Fab Lab Berlin. After I saw the Fab Lab in Helsinki, so the Aalto Fab Lab, which is connected with the Aalto University. So this is where I first got interested into makerspaces or Fab Labs in general. And I started to look for more information about those and possibilities maybe to build one. And then after I did my internship in Fab Lab Berlin, I graduated from the Aalto Media Lab, or the Helsinki Media Lab back then. Then I went to Barcelona for a bit more than half of a year to take the Fab Academy course, which is a global course. So there are global lectures and local labs, and basically after these global lectures, every week you have to work on a local assignment. So it's just connected with the with a place, so CNC milling or electronics. I'm going to tell about that later. So these are pretty much the spaces that I have seen in a bit more detail. I have seen pictures and read about many more spaces, but I think the first hackerspace where I was is London Hackspace. I hope it still exists. I think their wiki page it's a really nice space. You should go there if you have an opportunity. So that was my first interaction with a hackerspace. Or back then I didn't really understand what it is, but I was asking questions and I learned more. And while visiting Transmediale Festival in Berlin, so there were some events that were happening in Seabase, which is the sort of oldest hackerspace in Europe, I think. At least they are claiming so. And they are telling that the story is that this sort of alien spaceship that is covered with the city of Berlin. So underneath Berlin, there's a big round spaceship, and then in one of the darker streets of Berlin, you go there, there's a door and you enter Seabase, and this is how you enter that spaceship. There's an alien scanner at the door. So if you're human, then be careful. But if you're a member of the Seabase community, then you get the title alien. It's a nice space also when you're in Berlin. Make sure that you go there. Then Fab Lab, which is where I am now. Managing the space for a bit more than, now it's exactly 2 years. And I'm going to stay there also for longer. So that's more of like an academic space, more like a soft makerspace, so to say. Academic is not soft. It's nice. So it's connected with the university, and we are collaborating with researchers and also startups and businesses around. And we also get opportunity to work on our own projects here. Then Fab Lab Berlin is where I learned the most about how to run a makerspace and what are the problems connected to that. And I was also building a resource management system for them in terms of like a user-based system where you log in and then you can see what machines are available to you. You can turn these machines on and off. The system is connected with physical switches that are connected to the machines, and so on. And then at the Fab Lab Barcelona is kind of a central Fab Lab in Europe, one of the first ones in Europe, one of the first ones that were established after the original Fab Lab in MIT in Boston. So it's connected with the Architecture Institute there, the Institute for Advanced Architecture of Catalonia. And then, so I've been kind of very often to make Riga. So if you don't know that it exists, then make sure that you actually visit it when you are in Riga. Maybe some of you who are listening are even there right now. So it's a really nice space. And the people whom you can meet there, they can tell you everything about things that you can do in makerspaces in general. Is there someone from there who wanted to say something? Oh, that's like some voice from the background. Yeah, and so the picture that you see now, it's related to things that are happening right now in the Fab Lab. That's where I am now. So we got project grants and we are trying to work hard in order to finish these before Friday when we have to set them up. And these are units that are going to have electronics inside, basically more like walkie-talkies inside. And these are meant for making it easier to maintain social distancing while having meetings in the same space. But these were originally mainly meant for outdoors or lobby environments. So you can have a greater distance in between them, and then you can still talk with each other. while looking at each other, but from a greater distance, and also in a way that you don't need to shout, because the radio waves are carrying your voice around from one unit to another. So these also have microphones. So we were working with custom-made microphones. It's maybe not the recommended way to do it. So we just did it because we can, because the lab has all the tools and equipment to do it. So we stitched these together, and like we just realized that in order to make them perfect, you need multiple testing rounds. But these are just good enough for the structures that we have. And the main reason, it was not just because we can make it, but it was also because we needed a custom way how we can attach them to the surface where we want them to attach. They're sort of 50% contact microphones, because like the structure itself, it's made from plywood, and the plywood nicely resonates, and then this resonation goes into the microphone, and nicely resonates and amplifies the sound and goes into the microphone, and then into the sound card, and then to the radio waves. This is before painting, after cutting all the parts and stitching them together. A little bit more pictures from the microphone process. Here we tried to make a simple amplifier using the LM386 chip, which is, so this works, but obviously there are many things that you have to take into account. So with audio electronics, it's kind of tricky, because you need to take care of a decent power supply that is not too noisy. Then here, what is missing there, there's a chain of bypass capacitors which would remove noise from the power, incoming power. Then of course the audio cables, you see that they are not shielded at all, etc., etc. So you would need a few iterations in order to make it perfect. But we tried to make it because we can, and it was a fun process. But we just got commercial ones, like just a ready-made circuit that works much better than this one. And then some experiments with lights. So this is there's an LED strip inside, and the rest of the structure is self-made. So there's CAD design underneath, which is then 3D printed. So there are like 3D printed profiles, and then in these 3D printed profiles, you put in a sheet of acrylic that is actually laser cut to size. And as you see, everything fits nicely together. And here we are laser cuttable rubber. And you should always stay by the laser, otherwise you risk the lab being burned down. And then with this one, I wanted to say that it is always good to, so if you are a team of people, then it's always good to involve some paper prototyping in your process, because it lets you avoid a lot of trouble in terms of discussing what looks best. So if you have, let's say, 4 people, and all of them are artists and designers, then obviously you'll have many different opinions about how things should be. So how we solved the problem with these kind of things was that we chose to have a paper prototyping session where each of us was building something, and then automatically also the main limitations of digital fabrication come in, and you are being forced to work with these limitations in order to create the final form. And then at the end of the day, nobody argues. We were able to agree to the form and then move forward to the CAD design phase. That's rather. It was a rather long and not so well structured introduction, but I can continue. So the project is called Conch. So there are 4 participants. So we can now talk more about the maker spaces and their differences. And one good way how to talk about these things is scenarios. I would like to have several really nicely defined scenarios, but I just quickly came up with one, like with a town, with some people, with Peter, Una, and Lamdots. And then let's say, Peter from the town is he doesn't like that other people steal his IBAN and passwords, and they know his secret email address. And then his best friends are talking about, that there are these places called hackerspaces where the people who are really taking care about computer security and passwords and encryption. So these hang around there, and that it's a global network and so on. And then there's Una, who needs to 3D print something, custom for her shoes, or her BMW just broke down and she needs a custom 3D printed needle for the speed visualizer, speedometer. And then she heard from her friends that there are these places, makerspaces, so you don't necessarily need to own a 3D printer, that you can go to one of these spaces and they have 3D printers and you can actually print the things. And you can, even if you want, you might find someone who knows something about LEDs, so you can attach blue LEDs under your car and things like that. And you can weld some extra things onto your car. And then there's Limetoot, who says that we have to share knowledge, and that it's good to share knowledge and share skills, and this is how we build a strong community, and we want to make the world a better place, and we need to collaborate, not just locally but also globally. And Fab Lab is a concept that is very clear, and it's also global. It has global community and so on. And then, who is right? It's not that hackerspaces are the best ones at the moment. It's not that I'm trying to tell that. But yeah, let's dive into what are hackerspaces specifically. So as I told through this scenario, is that hackerspaces are more computer security minded. The people who hang out there, they are so there are different levels of geekness. So there's geekness who is more into computer geekness, and there's geekness which goes outside of the computer, which goes into electronics, and then maybe making things around electronics. And the geekness that is related to hackerspaces is more related to the insides of computer, and more particularly to the computer networks and encryption and computer security. And the people who are hanging out there, they're also, from my experience, they are more like misfits, that they are not taken usually seriously by the society, so they are developing the skills in order to fight back. So they are packed with all kinds of great skills that are ranging from engineering to electronics to programming to also social science background, so sociology, psychology, politics. So these people are usually very political. So they are not just having technical skill, but they are also very political. And anyhow, so these places also promote the sharing of knowledge, and also these spaces have a global network. It's just that they are less standardized, and they also usually have a laser cutter or an electronics lab, but that's not the main thing. So it's more like a space where people who have a different opinion about where the national or global politics is going, so where they are hanging out, and they are trying to protect their own and collective individualism, so to say. So that encryption is a big thing. So interpersonal communication shouldn't be known to other people, so that they are usually hosting things like crypto parties where people explain other people how to deal with encryption and passwords, and why it is bad to keep your passwords in a Google Sheet, for example, why it is also important not to use the same password in all the services where you're registered. So why it makes sense to keep a password manager and have randomized passwords and actually not know your passwords at all. So that's that. The makerspaces, so they're also techie driven, but so the people that are usually there, they're more business driven. So they are more keen to the benefits that capitalism can give to them. So usually you would see people who want to build something like a product for their startup hanging out in makerspaces. You'll see people who are looking for people who could be valuable for their business idea. So maybe like an investor, techie investor could be found in a makerspace looking for people or interesting ideas. And a makerspace is also not very clearly defined concept. So basically, if you have a room with a 3D printer and some flow or system around it, then you could easily also call it a makerspace. So you would make a website for it, and you would invite people to 3D print something. So that would be a makerspace. You add a CNC machine, not a big deal, still a makerspace. You add, you organize a maker fair, still a makerspace. Very good. Then there's Fab Labs, which is sort of a bit more clear concept of a makerspace. It's also less commercial, so it's not so. I would even say that it's quite communist, or maybe not communist, maybe more open to other ideas, to other concepts. Let's say some best parts from capitalism and best parts from socialism. So you put it together, and there we have the political idea of a Fab Lab. So which is also about opening up a space with tools to people who do not necessarily have the privilege to work with these tools, or do not have the privilege, the money or the capital to buy these tools themselves. So it's about sharing tools and sharing knowledge, and also collaborating. So as LimeDot said in one of the previous slides, so that's it. The good part is that it is a global network, and you are collaborating not just locally with local peers, but you are also listening and collaborating to the people globally. So it comes from Boston, MIT. So it started in the Center for Bits and Atoms, which is a part of MIT, and there still is a course which is called How to Make Almost Anything. And in order to run this course, they needed the lab. I am not sure whether the lab was first or the course was first, but the idea was to open up engineering tools and knowledge, engineering tools and skills to the people who are not necessarily engineers. So that means design students, architecture students, philosophers, poets, and musicians, to all the universities, so mechanical engineers as well. So engineers are not left out. So they have been using these tools. That it's not that they are not welcome anymore with the concept of a Fab Lab or with the course How to Make Almost Anything, but everybody is welcome, but it's just more people are welcome than before. And it was surprising fact that all of these people to whom it was open also joined the course, and they started to make incredible things. And from there, so the people who organized it, more particularly Neil Gershenfield, who is sort of behind this idea still, so he realized that people like it and that it makes sense to push it forward. So with the help of national outreach funding, so he came up with the standardized idea of a makerspace to be called Fab Lab. And the idea would be that if you make something in one of these Fab Labs and then you document it digitally and you send over a digital file to some other place, which is also a Fab Lab, it should be possible to reproduce it with the equipment there. So it is machines, and it is also materials that you can access there, and it is also the knowledge and education that you can access there. Then there are open innovation hubs, which is sort of, I see it as people trying to make business out of Fab Lab, and not really being able to do it to the max, and then adding a kind of a business layer on top of it, meaning that trying to take the people from the Fab Lab, or let's say also from a makerspace or a hackerspace, and then put them into this investment startup company, corporation, capitalism cycle. So it's, you go there, let's say, with your idea that you have developed in a hackerspace or a Fab Lab, and you present it to the business people over there. They decide whether it's worth something. They give you money in order for you to develop it for a year or maybe 2 years. And then they also provide with, they claim to provide you with all the necessary information and expertise in order to launch it and launch your products, that launch your thing into the market. Which is more like a businessy. I think, yeah, sometimes it's connected with government, sometimes not so much. Then there are like other things like bio labs, so which is more like an open makerspace, or like a Fab Lab concept around what you can do, all the things that you can do with biology, with biomaterials and bacteria and stem cells and whatnot. And then there are men's sheds, which is an Australian concept, which was created to solve problems with depression among the older generation, so that they created these. It was like a city level project, so they created these sort of spaces for older people where they could go and make things and share knowledge and so on. So I would like to actually catch up a bit more on these at some point. But it's an interesting concept, how to solve social issues, to host a number of workshops where people can meet and where people can make things. Then, yeah, of course, the community workshops, now here in Helsinki, in Finland in general, and there's a new trend that in libraries, people are setting up makerspaces with different kind of tools. So makerspace also, in a sense, that it's not very clearly defined, so that in each of the libraries, the tool set that is available for booking is different. So people can book the equipment and they can go to a library to not just read books or study, but they can also 3D print something, they can laser cut things, they can do vinyl cutting, they can do video editing, they can even play games, they can do VR stuff. What is more? Yeah, they can do electronics also. There, some of them have nice electronics equipment. But the problem is, since it's not standardized and they have limited budget, so usually the tools are there, but then there's not so much. They're not always there are people who actually know how to use these tools. So people book the machines. If they know how to use it, that's good for them. But then if somebody books a machine and doesn't know how to use it, then most probably the machine is going to be broken for a week or more until it's getting fixed. So other people are not going to be able to use it anymore. And then there are tech shops, which is kind of an extreme version of a makerspace. The digital fabrication tools are, you cannot do everything. So you cannot do, usually in a Fab Lab or a makerspace, you cannot do injection molding. You cannot do welding or CNC welding, or you cannot do metal milling. You cannot cut through 10 centimeters of steel. You cannot do metal casting for sure. So these tech shops, they are a bit more expensive makerspaces or Fab Labs, more like makerspaces, like an extended version of a makerspace where you can access these more heavier industry tools. I think last year or 2 years ago there was sad news from the U.S. that they established a chain of these tech shops, and it went bankrupt. But that was in the U.S., so there are still a few other countries where this concept still exists, and so on. So about Fab Lab. So I'm the Lambda guy who likes Fab Labs and who wants to share knowledge and be connected, share knowledge not just locally but also globally, and who wants people to work together to solve local problems with global knowledge. So that's so I've been a part of the Fab Lab network, and I'm promoting the idea around it still. And you can get more information about Fab Labs by following this link over here. So sorry, it's not clickable, but you can try to write it down. There's still a minute or two when the slide is on. So fab.cba.mit.edu. So that's kind of the main entry point to the concept of the Fab Labs. And you'll see a long list of of things that are related to that. So all the documentation, all the classes, also including the how to make almost anything course. And then the main differences or the main good things about a Fab Lab concept, as I mentioned before, is that it has a standard set of tools. It has a global network around it, and this global network is really nicely benefiting from the action of the Fab Academy. And Fab Academy is a 6-month course that usually starts in mid-January, and it goes on until end of June. And it contains 21 weeks or 21 assignments in total. So every week there's a new assignment. So it starts out with a week about the conceptual details about Fab Labs and about you thinking about your final project and what you could do with the help of a Fab Lab. Then you have to build a website, and you have to learn how to version control it, and you need that in order to keep up with the documentation efforts that are going to follow during the next week. So it's not just you learn, but you also have to prove your knowledge by documenting what you learn. So it's like a 50-50 process, and it's usually recommended also not to leave the documentation until the very last moment. Then you continue with CAD design, then which stands for computer aided design. So design where you use computer as a helping tool in order to make it precise. And then you continue with learning the machine. So you cover computer controlled cutting, which includes vinyl cutting, and then laser cutting. Then you learn to 3D scan, and you learn to model something so you can 3D print. So you learn the limitations of 3D printing technology. Then you learn how to CNC mill. You learn how to produce electronics, how to solder components on your circuit board. You learn also how to program electronics, how to build your Arduino basically, and you also learn how to make molds for molding and casting. So if you want to use silicones or different kind of plastics or other composite materials, and then during the final, so for the final project, you have to prove that you can use all these things together. So there's also one of the things that the idea about so one of the kind of ideas that the Fab Lab promotes is that you have the possibility to switch from technology to technology, so from tool to tool, very quickly. So you have these tools at hand, so you can sit at your computer, not just sit at your computer designing the circuit board, but you can actually get really involved with actually making the circuit board. And then after making the circuit board, you can immediately solder the components on it, and then you can use your computer again in order to program your board, and then you can again sit at the computer in order to 3D model some case for it, and then you can 3D print it, and maybe you want to make some nicer parts like rubber pads or some waterproof thing for it. So you can use molding and casting, and you can cast something from silicone, or you can laser cut rubber, and you can stitch things together. And in order to look it nice, you can make a vinyl cut sticker. All of these things in one room or in one lab. And it's a really nice course. It's really hard and exhausting, but it leaves a very good aftertaste. I recommend. yeah, if you want to join it, then here's the address. You have to go to fabacademy.org. So this application period is still open, so you can choose one of the approximately 60-65 labs that are there, including the Alto Fab Lab. So if you want to be here for a half year in Helsinki, so that's a possibility. Another thing, yes, so next year here we are starting an interesting thing related to the Fab Academy, which is academic overlay. So if you're a student and you would like to spend a half a year full of wonders in Helsinki, then you can also get academic credit for it. So the way how to make it work is that you could apply as an exchange student here at Aalto University, and once you get accepted, so you could come here for 6 months or a year, depending on how long you want to stay here, and you can take the set of courses that are designed as an overlay to the Fab Academy. And in our case, it is Digital Fabrication 1, 2, and 3, and then Digital Fabrication Studio. So altogether 4 courses. Yeah, if you really want to do that this or the next year, then contact me and can tell more about it. And yeah, I didn't want to talk only about the conceptual side. I wish I would have a bit more pictures in my slides, but next time. So I wanted to show also something practical. So digital fabrication is nothing without CAD modeling. So of course you can use the online resources such as Thingiverse to download all kinds of things, and if sometimes these designs are parametric, then you can change some parameters and you can export individualized things, but most of the time it's not exactly what you want. But if you want to 3D print or laser cut or CNC mill something that you exactly want, then you should learn one of many CAD or computer-aided design software packages. And I'm really pro open source software. So I've been using Fusion 360 as my main CAD modeling tool for some time. And then I heard that there is Freecad, which has been made really nice during the 2 past years. So the Freecad is a free and open source CAD modeling software, which is based on the concept of workbenches. So there's a part design workbench, there's even an architecture workbench, there's a CNC machining workbench, but the most useful one for modeling 3D parts is the part design workbench, but I'm going to get to that. So yeah, there are many commercial tools out there, like starting from Fusion 360, there's SolidWorks, there is Rhino, which has a nice parametric plugin, Grasshopper. So, but all these are commercial tools, and there's this online tool which is called Onshape, which is a CAD modeler in the browser, and then you can collaborate on a design in a similar way as you collaborate on Google Docs, for example. But the problem is that if you are an individual and you are, let's say, coming to a Fab Lab in order to avoid buying your own 3D printer or laser cutter, then you are probably keen on saving a bit more money and not getting into any kind of subscriptions or paying 1,000 euros for a license. And then you also don't want your files probably to just be stored somewhere in the cloud where you probably cannot access them later at some point. So basically, it's at the mercy of the company who is keeping your ability to design alive. And in my opinion, it's not cool. So it's that you're always, this little disciple of the huge company. And even though the company is nice, so we know that all the companies, they are driven by greed. So they want more money, and they are ready to go to do a lot in order to get that money. And even though if they are offering something for free today, then at some point they're probably gonna ask more than just free. They can ask some subscription. So there's always money involved. But some of the tools are very professional, and if you're using them, let's say in a company setting, and you have a bunch of clients who are paying good money, and you really like some of the tools. I mean, I think SolidWorks is even used in order to design nuclear plants. Although, like, there was a guy who a few months ago here at the Fab Lab who made a nuclear power plant in Freecad, and then he 3D printed all the parts, and so for kids to explore nuclear energy. And so basically he used Freecad in order to make a little cute, nice nuclear power plant. So you do not necessarily need a commercial tool, but some people, so if you're a big company and you're aiming for efficiency, then sometimes these commercial tools contain a lot of things that can make your workflow much easier. But yeah, today I wanted to talk about Freecad. So I think Freecad is really nice, and if you want to save some money, and if you want to do things that that are possible at the makerspace or a Fab Lab, then Freecad has all that you need, and probably more that you need in order to make that happen. So in order to get you a bit more into the Freecad world, I wanted to roll back also to the project that I'm working on right now. So one of the parts of the project, the conceptual parts of the project, is that it should be open source. So it's not just building these objects, but also releasing the designs online. Releasing the designs online so that everybody can download them and modify them. And actually, yeah, as I told about the concept of the Fab Lab, everybody who has access to the Fab Lab, they should be able to make them there and then try them out in their specific location, in their specific setting. Freecad is considered a tool that offers parametric modeling. Parametric meaning that you can have parameters. And in the case of Freecad, you can make spreadsheets, like tables like these. Something's going on with the monitor, so switching on and off. Yeah, no. So you can have a spreadsheet with parameters, and you can change these values. And the concept of parametric modeling is that by changing these values, you also change the design. So if we take a look at this, we see that the thickness of the walls is 18 millimeters. So this is the thin plywood for walls. Let's say that we want to adjust the design so it uses a thicker plywood. So if you don't want to kind of click on each of the elements individually, and change the thickness, or I don't know, rework all the design. So if you stick to the workflow of parametric modeling in Freecad, you can actually change this parameter, let's say to 50 millimeters. And it's going to update the design so that it has a 50 millimeter wall. So you can use 50 millimeter, 5 centimeter thick plywood in order to make this now. And then it's also being reflected here in the drawings. So you see all the pockets over here, they have been made bigger. So there are pockets for joinery over here. So these are all the parts laid out. So in all these parts, they react to changes that you make. I'm going to set it back to 18. We can check the drawings again, so you see all these pockets now shrinked. Yeah, I wanted to show this design also to explain how it works. So as every software, pretty much it has this menu on the top, which offers you to create a new project and save and revert and import and export. So this is what you can see in every other tool pretty much. You have preferences, of course, and view options over here. Then, yeah, you have some of these things exposed here as icons. And I think the most important part to in CAD modeling is that usually these CAD modelers, they have workspaces or workbenches, or so here these are called workbenches. And with workbench, you can access different set of tools. So here, like the software is built basically around the geometry engine. So it's kind of a core which has all the functionality. So you could, so it's actually as a core, it creates geometry that is basically described in mathematical concepts, and the library doesn't offer you a way how to even draw that on the screen. So you have to send some data sets to it, and then it will do some internal calculation, and then it's going to give you the result. But you have, as a programmer, you have to figure out how to visualize it. But so it's built around this kernel, and then the software itself is combining these features in a visual, like in functionalities that are then accessible by these icons. And there is a lot of hidden functionality that you kind of access through the visual layer of the software, but you can use scripting for it to access it. But that's too advanced for this lecture. Forget about it. And so the main part or main workbench that you would usually use with Freecad is the part design workbench, but there are other, such as the path workbench. It would allow you to create 3D milling toolpath. You can create a job, and then you can choose what kinds of tools you are using with your machine. But then, like, in order to understand this one, you need to know a little bit more about CNC milling in general. So it has robot workbench, where you can do robotic simulations. Then you can, Sketcher is an integral part, so it's very nicely connected with the part design workbench. And spreadsheets workbench, so this is in order to make the spreadsheets for parameters. Draw, so it's for making drawings like these and then exporting them in different formats, and many more. So architecture workbench for making architectural structures. So you can use this as instead of ArchiCAD or Revit or Vectorworks, which is very often used with architecture projects. And I would see bright open source future where even companies who are making projects for governmental organizations, so let's say library projects, are being built by using Freecad and Arc Workbench. I really see that happening in like 10 years, because like during the past 2 years, this software, Freecad, has developed a lot, and it's really, really powerful. And I'm running it on Linux, by the way. So like using open source operating system, and then also using open source CAD modeling software in order to build it. And in order to demonstrate its possibilities, I wanted to kind of zoom into one of the parts that I was building for these. So this is a profile, like a part that is intended for LED lighting. So this is one segment from many, so you can actually put this. I'm going to hide the roof and also the walls maybe here, some of the base features. So it was important to have this roof in order to get the precise angle here for this triangle, so I can match it in perfectly, and then 3D print and attach it to the screws to the existing platform. So yeah, this is why CAD modeling is great, because you can make these kind of super precise things. So yeah, and so this is for holding a LED strip inside. So here on the bottom, there's a LED strip going in. Then there's a little channel for the cable. So here I got a part where you have a socket for the power plug, and it's 12 volts coming in and to the plus terminal of the LED strip and to the minus terminal of the LED strip. And LED strips, they usually have sticky tape, so they're usually put on. They're kind of a sticker, and the glue is really nice and sticky. So and you can put it. So when you're just testing, then you don't need to use the glue. So it's okay to have little snap fit feature over here, so you can actually slide these LED strips in there. Yeah, there are 3 parts. So this is the profile that you can then repeat like 1, 2, 3 or more times in order to play around with length. So each of these is 10 centimeters, and then you can. Usually these LED strips have 25 millimeter segments that you can then break away easily. Did I have like some data sheet somewhere? Let me check. So where do we have the show all history? GT. American Bright Optoelectronics. Yeah. Yeah, so I'm using these LED strips, and the thing is that usually these sort of components, when you buy them from electronics shop or supplier, then you get a data sheet. And in that data sheet, you can see all the information that you need in order to make your CAD design. So here you can see that the width of the LED strip is 10 millimeters, and then it has these 25 millimeter segments that you can break away in order to control the length of your LED strip. And then you also have a profile view. You can see that it's 2.5 millimeter thick usually, and then for 24 volt version you have different settings. So sort of similar, different. So probably they make it 2 times bigger, because otherwise the individual segments would burn between them. Minimum length is really 50 millimeters for that power. But now I'm just speculating. Yeah, so these data sheets is a really important and interesting source of information usually. And I use this data sheet in order to decide what would be the groove size over here. And what I'm going to do now is I'm going to show you how to make just the profile over here, so that you could get a basic idea how to work with it. Freecad. So I'm going to start with a new project. Here we go. You would usually open it up, make a new project, and then you would go to part design, workbench, and you would start out with creating a new body. And yeah, for the workbenches that you can select here, you can usually see the default actions that you can do with them over here. So my layout, I think, like if you download Freecad on your computer, you will just see the same icons, but like maybe located somewhere else. Also because you can drag them around if you want. I'm not gonna do that now. So when you so here in the combo view, you can see the the structure of the design that you want to build. And if you want to have multiple parts, so these multiple parts, these different parts are called bodies. So here you can see that there's the application level, then there's the document level. So if you go and save it as let's save it as demo. So you see that the file name appears here. And yeah, by default, the body is called the body, and we can name it. Let's say as a profile. And each of these bodies is going to have an origin. The origin usually contains all the axes, so X, Y, Z axes, and the plane. So these are important for you to get started with, and for the design to get orientation in 3D space. I'm going to hide it for now. So once you created the body, so now it's empty, you don't see anything. So you need, usually like a CAD workflow starts with a sketch. And since it's a profile, it's sort of an easy task. So we need to click on sketch, and then we need to choose a plane. So I'm going to choose the XY plane. And we are being switched over to the sketcher workbench. And it's for creating 2D sketches, so basically 2D drawings. And as you see also the tools here, they change. So you can add a dot, or you can add a line, or you can add a circle. Oh, no, this is more like an arc. And if the line is blue, that means that it's construction line. Construction line is you can use for referencing different elements in your sketch, but it's not going to be taken into account when you then try to do something extra with the sketch. And this button over here is toggling basically in between drawing, sketch, construction line element or not. You can also select the elements that you have created, that you did create, and then you can click on this button, and it's going to turn into either a construction line or a real line. So yeah, you can create a circle, you can create a polyline, like so. And yeah, usually, so at least for me, I use the polyline a lot. The good thing about CAD modelers is that instead of doing drawing and kind of doing the calculations yourself or specifying the relationships between elements yourself or keeping them in mind, is that it usually has the so-called constraints. And so for me, it was always a kind of a mystery. So why they are talking about these concepts in geometry lessons? So it's like things like lines are parallel to each other. So even though geometry was one of the most interesting subjects for me, I never understood where I can really use it. And then when I first got to graphic design and started to use Illustrator, so none of those concepts were actually there. And then when I got into CAD modeling, finally, I realized that this is where they actually build them in. So you can select these lines, for example, and you can make them parallel by selecting the parallel constraint. And you can select these two lines over here, and you can make them perpendicular. And furthermore, you can select these two lines, and let's say you can make them equal. And you see this whole update by itself. Then let's say we want to add this here. I can make this perpendicular to this one. This is still movable. We can select these, we can make them equal. Select these, we can make them parallel. would be nice to have perpendicular as well. And you can select all these three and make them equal like so. And then you can select these points and make them coincident so that it snaps like this. And Freecad has vertical and horizontal constraints, so you can constrain it to the horizontal axis like this. So now it's just like so. And I can make these as construction lines. And what is cool, I can specify a dimension for those. And I can specify a different dimension in between those points. So I can select 2 points and I can specify a different dimension. And as you see, at this point, it's turned green, which means that the sketch is fully constrained. And generally, this is what we want to achieve with our sketches, so that there are no unknowns, so to say. So the geometry engine is taking these constraints that we set, so these 2 lengths, and then the relationships between the elements that we set here in order to build this drawing. And so the software doesn't have any questions, so there are no more calculations to be done. So it's sort of carved in stone in a way. So it's nothing that can move randomly. That's important. And then what do we do with the drawing? So if you are familiar with 3D software, did you know that with 2-dimensional things, you can do extrusion, or you can do revolving, you can do lofting, sweeping, so all these things. And usually things start with extruding, and here it's called padding. So I'm going to extrude this 20 millimeters like so, and look at that. So we put a cubicle, so like a little chocolate bar. And furthermore, you can then continue building it by selecting one of the faces, or the side face of it, and drawing a sketch on it. And what is nice is that you can reference existing geometry by using this tool over here, so that you actually can change the previous sketch. So I'm going to make this as a construction line, and let's say, I don't know, construction line over here, like this perpendicular construction line. Let's draw a circle over here. And what we haven't used yet is the radius tool, so 4 millimeter radius. And now it's green, so it's fully constrained. I can close it and I can pad again. And we have something like this, 65 millimeters. Then furthermore, we can select like individual elements, such as this edge over here. And we can do something, so all of these tools are actually usually based on things that you can manufacture. So chamfering has existed before CAD modeling existed. So chamfering is basically making your edges a little bit chamfered so that you can, if you have a negative part of this one, then you can snap it together with something. And let's say if we would have another part, let's make this other part. So I just created a new body, and we'll name it to cubicle 2. And I can create a shape binder with the geometry from something else, and use this shape binder as a plane for a sketch. And then I can reference geometry from this shape binder. Yeah, this happens because I need to have this invisible in order to be able to select. So you can select these guys over here, and then you can snap a rectangle. See, you can create a sketch that is based on the geometry of another object, and I'm going to hide this one, and then I can use this to pad it. Time 15, and I can do a Boolean operation. So I need to select something. Basically, I want to cut. I want to cut the profile from the cubicle. So I'm gonna wait. Cubicle 2. Then yeah. So here we go. Like the only thing that I would like to have is that so the other part is still visible. In order to do that, I need to create a clone. This is my favorite icon here in the software. Was it Dolly? Yeah, this is cute. So to create a clone, you need to click the sheep, and then you can use the cloned object. Oh, let's do it so that I'm going to hide the profile by pressing spacebar. You can hide objects over here. Cut and down, and then you still have two parts. And furthermore, you can then individually change the transparency of those, so you can see what's going on. Yeah. So this was just a quick example of basic features, but I wanted to show you how to create this one specific profile that I had in mind. So basically this one. And in order to create that, of course, we just start with a body. So we're going to call it an LED fixture profile. And of course, you start with a sketch, and let's start with XY plane. And let's just start drawing some polylines. So an approximate shape could be like this. Then we want to have a little pocket for the acrylics, for the semi-transparent acrylic. Then yeah, we want to have like a wall. And then we want to have a little snap fit for, I went a bit too far, wait. So here we want actually to have something sort of flat, like so. Yeah, and then this is going to be the flat part. And it's going to be the final form. But of course, the final form is not constrained at all, so it's totally undefined. And so let's start with some knowns. So we know that this is going to be the place where the LED strip is going to be. So let's make it horizontal. It's already horizontal, so we want these to be vertical. So we also want these to be vertical. So yes, basic horizontality stuff. Yeah, horizontal, vertical stuff like this. Then also here, we want these to be vertical. Then this, then that. Horizontal. Yeah, and we want these to be equal, and we know that this is going to be 10 millimeters. But see, we're very much out of scale here. 10 millimeters. We want everything to be a bit bigger here. And we know also that this part over here is going to be 2.5 millimeters. And we want this to be equal to that. And then we can decide how much do we want for the LED strip to be snapped into the groove. Actually, I'm going to make it 2 millimeters because it's sort of more like a round shape the LED has. So if you look at this one, so you see it has like a fillet on the edges. And so let's set this to something like 1 millimeter. Should be enough. So just have basic snapping capability. And also can make these equal. We want these to be equal as well. Then, yeah, here we have something that is not vertical still. We want these to be equal. We can decide about the thickness. So this could be like 2 millimeters. Totally fine. And usually another thing that is known is how big is going to be the acrylic sheet that you're going to slide it in there. So we could set it to 20 millimeters, like so. And also what we know is usually what is the thickness of the material. In my case, it was 3 millimeters. And it is also usually important to leave a little bit of extra space. So if you're 3D printing, then it's usually going to be a little bit of offset, or the filament is going to flow over the edges a little bit, so you will need some extra space or tolerance. So 3.4 is too much, so 3.2 is a decent value here. Then you can also decide on how much material you want to have covering the your acrylic sheet. And make it equal, almost there. And I think finally we can also decide about the length of these. Let me put it at 30. Then we can make a construction line between here and there. and then make a construction line in here and there. And here I'm going to apply the parallel constraint in order to make them to be on the same line. And in order to avoid motion like this, I'm going to make these equal. So now I still have to work on these. And I think I can make these equal. These have to be equal. And I can also decide how far I want this to be from the edge, or actually better to focus on the corner over here. And we don't overshoot. And 2 millimeters over here. It's still not very symmetrical. One thing, so how to make this to be in the center. So I think that we can use symmetry constraints in order to make that to work. We have to select 3 points and select symmetry. So now they are symmetrical. Now there are still a few things that are floating. Why? And I think I can also create a construction line over here. And I can make these construction lines equal. So there are a lot of different ways how to do this. Well, using construction lines never hurts. I'm going to make these parallel. So you see a lot of constraints. You probably could do it in a much easier way. And here also I want this actually to be equal with that. And now is, and I can also decide the angle in between here. So let's make something 70. So in this case, I don't have like an existing structure to support this. Okay, and then I think still need to somehow manage these. I think we're gonna delete here and connect these with the coincident. Oh no, there's some madness going on. Oh. Oh no. Got a little bit out of hand. Let's see how we can fix this. Yeah, that's done. And let's snap this point to the center over here. Yeah, and now it's nice and constrained. Now I can close it, and we can extrude it by using add feature and 100 like this. And here it is. Another thing that we might want to have is sort of a fixture. It's going to be quite hard to add it here. Or let's say we want to put it underneath the actual profile. So we can select the profile rail over here, the sketch on it. Again, can reference from geometry. And we can draw some construction lines. Like so. Now, I'm going to make these equal. And also I'm going to make these equal. And I'm going to use this point here to draw a circle. And I'm going to make it a normal line instead of a construction line. I'm going to add a diameter, which is going to be 1 millimeter, no, radius 1 millimeter, which is going to be good for 2 millimeter screws. And I'm going to hit close. And I'm going to use this pocket operation, which is meant for cutting through the material. As you see, it's cutting 5 millimeters deep, but as an option, you can select also the through hole. And now we have a hole. And in order to make it even nicer, we can select the edge and we can chamfer it so that you can use the sink-in screw and it's going to nicely level out with the surface. So in order to do this, you need to check what you need to know what kind of screws are you going to use. And then let's say we want to build some extra fixtures. So we want to cover this with something. And then drill a hole for a connector over here. So we can do that by creating a new body. And I'm going to call it lead fixture. Okay. And I'm going to create a shape binder. So in software like Fusion 360, you can just select the face and start sketching on it right away. So it does it all automatically. But here, so it took me some time to realize that shape binder is the thing of Freecad. So this is how you connect different parts together in a design. So like this, you click add geometry, you select the face or an edge that you want to add, and you hit OK. And from here on, you can hide the previous one, and you can start sketching on the shape binder itself. And you can basically take only the parts that are needed. Like these, for example. Maybe you need also to know where this part is over here. And you can use the polyline to just connect the dots. So you can see when I hover elements, Freecad offers me to add some constraints automatically. In this case, it's the coincident constraint. I can select these 3 edges and I can make them normal lines again. You see it's all green, so basically already constrained. One thing that I would like to have is the circle over here. So it's going to be for 8 millimeter thread, like 8 millimeter diameter, so I need 4 millimeter radius. I will give a little bit of tolerance at 4.2. And I want it to be aligned against this point over here. So I'm going to draw a line, construction line from here to there. Make it a construction line first. I'm going to set this line to vertical. And another thing that I would like to do is to put it exactly in the middle between this line and the bottom line. So first I'm going to make this into a construction line, make it perpendicular, then select these two, make them equal, and you see it's all green, and I can go, and I can again use this. And in this case, I'm going to make it just 4 millimeters. And here we go. 2 parts. Like another thing that you would like is probably to design some snap-fit things that would fit these together. And this is something that involves a bit more energy and time. Yeah, on top of this, so this is just a preview. So on YouTube, there is a lot of material about Freecad. And I don't really even know what to recommend you first, but there was one really nice where the guy actually showed how to build a shed in a series of workshops. So how to use the architectural workbench. This is really nice. And for there are many nice tutorials. Yeah, so art design tutorials. There are many authors of these videos and many different ways how they explain things about Freecad. So the way I did it today is not necessarily the best one, but I hope you picked up something. So I recommend you, if you're interested in Freecad, to kind of go to YouTube and check all these videos out. And on top of that, of course, visit the official website and check the documentation. And here is a wiki with all the most up-to-date information about how to go about Freecad. Not around, go about Freecad. Freecad is nice. Should be going with it wherever you go. What else could I tell? Then there are some things that I mentioned. So if you are not into CAD modeling, but you're okay with designs that are already made by someone, so Thingiverse is a good resource. I mean, I'm not designing everything from scratch always, but you know, there are some parts like these. Sometimes need some clamps. This is nice for standing. So this is a really nice resource. And sometimes it has parts that have been designed parametrically by using OpenSCAD, for example. And which means that it contains a SCAD file. And OpenSCAD is another nice CAD modeling software which has a really simple interface, which looks like this. Fortunately, I don't have it installed in my system at the moment. But yeah, so if you're into programming and version control and doing complex parts, then this might be the tool for you. Because then you could open up one of these files and you could actually change the parameters. But let me just try. I'm gonna install it. Here you go. And we can open the project that we just downloaded. And as you see, it has two main parts. So instead of having tons of buttons of all the features and workbenches, it just has one single 3D view, some parameter pane, some debugging information, and the code itself. And it needs this file in order to function properly. I'll go back to the website. And actually, if some of you know the MakerBot, which is the first open source 3D printer that I started to make after the FDM 3D printing patents expired, then if not all, then most of the parts that were for the 3D printer that were actually made in OpenSCAD. And what I need to do is I need to open it again. And I can render it. Oh, wait. Where am I calling the functions of those? Okay, so there's the example one. I think I need to uncomment this one, then render. Yeah. Here we go. So it creates a sort of heavy design. Can I just center it? Yeah. Further, like thread making is very resource intensive operation indeed. But I hope you got the idea here. So I think this is also the end. I hope that it provided some interesting information for you. And would it be possible for you to ask some questions during the remaining minutes?
I have a question. What is, besides it being open source, what is the biggest advantage of Freecad over its commercial counterparts?
It has some nice scripting capabilities that other tools do not have. So it's built around the Open Cascade geometry engine, and basically anything that you don't see in the user interface, you can access via the scripting interface. And it has community around it. So if you're looking for a script that does something that kind of should be there, then you are usually able to find it in the open forums. So like macros and so on. So it uses Python as its scripting language. It's also not like something, not something that is developed by a company and that is only compatible with the products of the company, but it's like an open programming language, and you can actually use whatever other libraries you're using with Python. So let's say if you're in machine learning and you use TensorFlow, you could actually include TensorFlow into your Freecad flow, and you could combine machine learning with CAD modeling and things like those. I'm not like playing with TensorFlow myself so much, but that's a possibility. Then the other thing that is nice, that it has nice integrations. So let's say the same OpenSCAD that I just showed last. So it has an OpenSCAD integration. So OpenSCAD is nice for making some mathematical, more like programmatic design. So really for individual parts. And then if you see a better way how to make a parametric part in OpenSCAD, and then you want to use it within Freecad, then you can actually do that. There was one more thing that I wanted to mention. Freecad. Okay, maybe I'm gonna remember later. So there are several things that are good, but yeah, please keep asking.
Do we have any other questions?
What would be better to make? What should we make? For like, I still have no clue. Because as I understand, we have to make something.
No, it really depends. Some people believe that we don't have to make anything in general. And some people believe that we have made everything that we need, and I mean, like maybe the existing things are enough, and we should just repair them. And then sometimes when we are about, we need, if we are kind of, let's say, moving towards a repair economy, so where we stop producing things, but we rely on existing things and we repair them. And sometimes we will, I think at that point we will meet many instances of missing parts. And then in order to make these missing parts, you would sometimes just find drawings of these missing parts. And in order to produce these missing parts with a 3D printer or any other technology that is around, you will need like some sort of a CAD design. So if you are into the ideas of let's say repair economy, then you could start with looking for any kind of broken equipment in your house, and you could check that maybe there's a broken part, and you could make it with Freecad.
Okay, that sounds cool. Also, I saw that on my computer there is AutoCAD. Can I use that? Is that similar?
AutoCAD is considered like a software that is going to die soon, and nobody really recommends using it. So it comes from Autodesk. It's really old software. It's based on old file format, and it's also commercial. There are better tools. Like actually, if you want to learn something similar as AutoCAD, then maybe you could try LibreCAD, which is a two-dimensional drawing software, which is very similar in terms of interface to that of AutoCAD. I mean, architects still use AutoCAD, but whenever we have the Fab Academy lectures and there are lecturers who actually know people from Autodesk and AutoCAD, they always mention that, yeah, there's AutoCAD, but do not use it because it's old and it's going to crash soon. So consider using something else.
And also then there's a question. If there is AutoCAD, is like it's not a very good option, and SolidWorks, it's also bad.
SolidWorks is good. SolidWorks is the software where you can build a nuclear reactor. It's very stable. It's well supported. There are many companies using it. They are paying a lot of money to to the creators of SolidWorks. I think it's the Dassault Systems, the company. Or maybe I'm mistaken, but yeah. So it's very good software, but if you want to use it commercially, you might need to say goodbye to a lot of money. Meaning, if you're just playing around, it's fine. And but then, so what I usually why I recommend Freecad is because then, let's say if you use your university time in order to learn Freecad, you graduate the university, and you still have Freecad and you can do your project. But let's say, imagine a situation where you are in a university for 2 or 3 years, and you're learning SolidWorks because one of the university's computers have SolidWorks, so you have a student license. And then your student time expires and you're left on the street without a student license, but with the knowledge of SolidWorks. And then the only option, or like the fastest option to get back to using your SolidWorks skills is paying the company who produces SolidWorks and starting again from there. But it's good.
That sounds interesting. Thank you.
You're welcome. So any more questions?
Well, you can stop sharing your screen so we can see you instead of the website.
That's a good point.
Thank you. And I have a question. I think previous questions were directed more at the workshop that we will start tomorrow. And about the workshop, you can do whatever you want. You don't have to build anything if you don't want to build anything. I hope you will make something and you will get inspired to make something that is interesting for you. For us, you can think about, you can browse around and you can make something that you want. And maybe don't start from scratch, but start with an existing design somewhere that you can find online. But I have a question. What is the future of prototyping? We had this question yesterday, and I also want to ask it to you.
Oh, that's a very philosophical question. It depends on what's going to happen after the pandemic. I think that, like what we can see now, that there are a lot of companies going down. So it's creating a lot of chaos, and probably we're gonna experience this chaos during the next 5 years or so. And I think that the thing with the economy that is happening right now, it's going to motivate many people to change something in the way we are living right now. And in a way that I mentioned the repair economy, and I think that the prototyping could actually fit in there very, very well, so that you probably, like, a lot of businesses are going to go down, and you are not going to be able to buy so much stuff as before. But then I think that you're gonna probably be smaller businesses which are going to produce products on demand, and then in order to create these products on demand really quickly, rapid prototyping is going to play an essential role. And thus, I think it is going to be more and more important to master these digital skills, to master CAD modeling and programming and online conferencing, in order to cope with the effects of this virus situation and kind of the destruction that is going to follow. So the future of prototyping, I think it's bright, and it's gonna become more and more available and less dystopian. So we're gonna be able to build a less dystopian world if we are going to master open source tools that are developing really quickly, as you see, like this Freecad. It's basically just a group of enthusiasts who put it together. I think there's maybe like one button on the website which says please donate, but I think even I'm donating to Blender, I'm donating to open frameworks. I'm donating to KiCad, but I think I haven't donated to Freecad yet, but I would recommend you to do so. But it's like pure enthusiasm, and the software, it's like to make something like this, it's not easy. But the fact that it exists, it kind of shows that there are many people out there who believe that in the future, we shouldn't, that in general, we shouldn't strive for being locked into the arms of big companies, because when we are just like freely or let's say openly or without any kind of friction going into using tools or products of big corporations and not really spending any time to master any alternatives, so then we're basically locking ourselves into the dystopian future where there's like the one big brother who can change the freemium version into a subscription model and can kind of pull money out of our pockets, like €1 at a time, and then more and more until we don't have anything to breathe anymore. So yeah, I think that's the future of prototyping. So open source tools and shared knowledge about those, so that more people learning those and more people actually considering repairing things on their own rather than buying new things.
If no one else is talking, then I have another question. How do you deal with the plastic waste in Fab Lab?
Yeah, that's a good one. So we are now collecting it, and so actually in the storage we have a machine that is meant for making this plastic into filament again. So you can basically, yeah, but it requires time and it requires some extra equipment. So you need a grinder in order to grind it. And then you need also some extra equipment that kind of makes sure that the pull of the filament thread that you're getting is constant, so that you can get the same thickness all along the way. Another way to use it, what I would like to do here is to use it for injection molding experiments. Maybe you have heard of a project that is called the Precious Plastic. They have an open source, very basic injection molding machine. And then if you have a Fab Lab and CNC milling capabilities, then you can make molds for injection molding, ideally from aluminium, but you can make it also from hardwood. You can connect it to this injection molding machine by using threads that you have installed there. And you can melt and inject plastic into the mold, and you can create copies of objects really quickly. Or like in my case here, I really don't have time for recycling plastic so much. So I'm rather looking for external services around. And there, like a month ago, I had an interview with a student from the sustainable design department, and she was basically asking the same question. So what we are doing with how we are recycling plastic, and there are many spaces similar to the Fab Lab around, and all of the spaces, they are not doing anything because basically they don't have time. So the plastic is piling up, and the conclusion is that there's no service that actually does plastic recycling. So the idea was, like the collective idea was to actually make a spot where there could be people who would do it on a regular basis. So there's one person working there and focusing only on recycling plastic. But on a lab level, I think in order to make it, let's say in a university setting, I think that I would go for this cheap open source precious plastic injection molding machine.
Do we have any other questions? No, then I can continue. So, what is your favorite part of prototyping?
Can you repeat, because I didn't figure some words?
What is your favorite part of prototyping?
When I put it together and it works. Yeah, and then when you see that the digital becomes actually tangible. So that so because like in digital fabrication you spend a lot of time on the screen, so kind of making lines vertical and horizontal and defining angles and writing code and all of that. But then it also takes some time to kind of figure out the machines, set them up so that they actually do the things that you want them to do. And then, like after days of work, you actually get this little board or a case or something, and then you want to try if it fits together. Sometimes it happens with the first go, but most of the times it happens with a few iterations. But then, like after a week or a month of work, when you kind of see that it's you're holding this thing in your hands and it fits together and it works, I think that's the best. And like the realization that you actually did it yourself, and then like a retrospective of all the things that you learned along the way. Yeah, I think it's just like if you do prototyping, then your life becomes full of joy.
Thank you. That was a great answer. If no one else here has any questions, do you have some words of inspiration for us?
Excuse me, installation?
Inspiration.
Oh, inspiration. So since we are living in capitalism, I think I'm going to practice a little bit of advertisement. So if you're interested in projection mapping, then check this out. So it's a tool that I developed as my master's thesis, and I'm still keeping. So I'm still developing it, and I'm planning some updates for this Christmas, such as web interface for the Raspberry Pi. So when you install this on your Raspberry Pi and want to do projection mapping, so you don't have to connect the mouse and the keyboard to it, you'll be able to connect it via Wi-Fi and open a web interface and do the mapping through there. And then the second one, like major update that I want to finally get down to is I want to make this run on the Raspberry Pi 4. And as you know, Raspberry Pi 4 has two 4K outputs. And if you are familiar with projection mapping and really powerful projectors and 4K output, then you can naturally understand what it means. You can download this as a disk image, and you can use the instruction manual that you can access by clicking this link over here in order to install it on your SD card and actually make your Raspberry Pi functional as a projection mapping media player. Or you can, if you're familiar with open frameworks and you are doing interactive projects already and you want to add a pinch of projection mapping, then you can use it as an add-on. And just need to go to GitHub and read the instructions here. So that's advertisement from my side. And another thing that I would like to do is also, if you're interested in the Fab Academy and all the crazy prototyping things and the prototyping lifestyle, and so and you want to learn, like spend half a year really seriously getting into it, consider taking Fab Academy at the Fab Lab together with me and some other folks. If you really want to do that, then go to fabacademy.org, choose Fab Lab as your lab, and also send me a message. That's it. Thank you very much. It was a pleasure.
We have another question. If you would have to choose laser cutting or 3D printing, which one would you choose and why?
It really depends on what you want to make. For precision, I would choose laser cutter. So for more complex forms, I would choose 3D printing. It's really I think like both of them are essentially at the core of it. They are the same machines. They are tools that are being put on an axis that moves in X, Y, and Z direction. And the only difference is that the 3D printer extrudes plastic, or there are also other technologies. And the laser cutter is just beaming a straight laser beam downwards. I would probably choose laser cutting because, like, if there really would be a fundamental choice that now we need to choose which is the technology that we need to get rid of, then I would rather, the 3D, because you can do 3D printing with laser cutter actually. Because consider the laser, so the selective laser sintering technology, SLS 3D printing technology. You're just basically laying a layer of powder, let's say nylon or aluminium, or let's say titanium powder, and then having a laser beam which is then melting this layer of powder. And then another layer of powder comes over it, and then the next layer is sintered on top of the previous one. So basically, from a laser cutter, you could build a 3D printer. So if you want like a really fundamental answer, so whether I would choose 3D printing or laser cutting, I would say that I would choose laser cutting, because then from the laser cutter, you can build a 3D printer.
Thank you. Thank you. And if we don't have any other questions, then we can say thank you. And we can finish the lecture for today, and hopefully go Google some Freecad and Fab Lab.
Yeah, thank you. You were a great audience. There were a lot of questions, and I wish I was there for a laser cutting workshop. Yes,
we also wish you would be here, but maybe in the spring.
Yeah, next year for sure. So Sputnik 5 is coming. So hold on, and we're gonna be soon free from the virus.
Yes.
Thank you for all the information. Thank you.
Thank you. Bye.
Have a nice week. Bye.
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 Thank you.